So what are we going to be doing today? We are going to talk about data cleaning, what it is, why it's important, some benefits. We will do a software overview of the tools that we're going to be using, just so you can get a little bit of a history of them, and then go through some hands-on exercises. So what is OpenRefine? OpenRefine is an open desktop tool that can be used for cleaning messy data. It was previously known as Google Refine, and in 2012, Google stopped supporting the project, and maintenance has been taken over by a dedicated team of volunteers from around the world. It looks like a spreadsheet, but operates like a database in your web browser. And it allows for a low barrier of entry point and data cleaning alternative to Microsoft Excel. The GUI means that novice users can feel confident in applying basic data cleaning strategies and algorithms, while the advanced functions and the use of GREL, which is also known as General Refined Expression Language, allow for more advanced use cases and scenarios. Today, we're going to be focusing on just like a very gentle introduction, so don't worry about that. The application keeps data private on your own computer and works by running a local server that you interact with in your web browser. It looks like a spreadsheet, operates like a database, and this allows for increased discovery capabilities beyond programs like Microsoft Excel. It comes with many preloaded transformations, but expressions can be written in General Refined Expression Language in Jython, which is a flavor of Python, or in Clojure. There are many extensions, reconciliation services, client libraries available for users, but remember that in using some of these external services, depending on how they're processing your data, they may be taking your data off of your local machine. So read the documentation about the extensions before you start using them to make sure you're keeping with your data management plan. And the other great thing about OpenRefine is that robust communities of support exist that can be tapped into using mailing list or with Stack Overflow. A note that if your data set is more than 1 million rows, you will need to increase your RAM and server memory that you have allocated. But 1 million rows, we're not going to be dealing with anything close to that here today. So that was our data cleaning software. The other tool we're going to be using is Voyant, and it is an open source web-based application for performing text analysis. It was developed by Stefan Stinclair at McGill and Jeffrey Rockwell at the University of Alberta, and it continues to be updated. It supports scholarly reading and interpretation of texts or corpus, particularly by scholars in the digital humanities, but also by students and the general public. It can be used to analyze online text or ones uploaded by users, which is what we will be doing today. And Voyant was conceived to enhance reading through lightweight text analytics, such as word frequency lists, frequency distribution plots, and quick displays like word clouds. Its interface is composed of panels which perform these varied analytical tasks, and these panels can also be embedded in external web texts. Researchers have used Voyant tools to analyze texts in a wide range of contexts, including literature, language teaching, healthcare, system architecture. Describing approaches to studying the internet using web scraping, one researcher noted that Voyant Tool Project is an excellent source to learn about kinds of data that humanists can extract from the internet because it already supports text extraction from web pages. So if you're thinking about how could you use these tools outside of what you're doing today, Voyant is great for either being a direct pipeline if you are doing any text analysis on the internet, or if you're looking, what we will be focusing on today, at looking at just like what exists inside of your data set and things that you might need to think about cleaning up before you get started.
So before diving into what data cleaning is, we're going to show you a bit what messy data can look like so that we have a better idea of what we're working to clean. We're going to start by creating a word cloud with data that hasn't yet been cleaned. You're free to follow along on the screen or go to voyanttools.org and do the steps there yourself. So if you want to do the steps along with us, we're going to be using one of the spreadsheets that was linked in the workshop materials titled Exercise 1. So it's part of a larger data set. We're using data that's from the University of British Columbia that looks at preferences in Halloween candy. The data was manipulated to some extent for the purpose of this workshop, but we have the original unmanipulated data linked on the workshop website as well. So exercise 1 includes only one column from the survey. It's the province column that reflects where each participant in the survey was from. So we're going to go to Voyant Tools. And then from there, we're going to click on Upload. And we're going to go get our exercise 1. You're probably going to get a message like this, but that's okay. We're going to click yes. And then when things open up, you'll see there's a lot of different windows, but what we're going to focus on is the word cloud window here. So to make that a little bigger, we're going to go to the top of that box and we're going to click on this little box with the arrow, and it's going to open it up once we click export into a different separate tab. So this is our word cloud. We can change how many terms we can visualize, up to 500 all the way down to 25 words, depending on what we want to focus on. I'm just going to zoom in a bit so we can get a better glimpse of this. Things will shift around as you zoom, but if you're not familiar with word clouds, the more a term shows up in the data that you're using to populate the word cloud, the bigger the word will be. So as we take a quick look, we see that Ontario is pretty big here, Alberta's as well. But at the same time, we're seeing that this is not exactly an accurate picture of the data we're looking at, because we do have Ontario here with 83 counts, but that's not factoring people who probably misunderstood we were asking for province and used Toronto or their cities, like there's Oshawa somewhere right here. So those aren't counted in that Ontario count when they should be, nor are ON over here. We have typos in some places. We have this, which I'm not sure what that was intended to be, but it's not a province. Some of our provinces have been split into different categories. So we have BC over here, but then we have Columbia and we have British. We didn't remove the headers from our data before we imported that. So you have things like Q5, which was part of the title for that particular column. So there's a lot of things here that could have benefited from being cleaned before we would have opened it up in Voyant. So going back to our slides. We're going to start off by defining what data cleaning is. So data cleaning is the process of reviewing, editing, and quality checking your data to improve its overall quality. It can be useful if you're creating your own data or if you're using someone else's data, as well as if you're combining different data sets together. Data cleaning doesn't necessarily mean that the data you're using is messy or it's of poor quality. It might just mean that it's not in the right structure that you need it to be to accomplish your goals. So for example, maybe you're reusing someone else's data and they had their values in inches, but you're going to want to convert those to centimeters. You might have a single column combining your latitudes and longitudes, but you'll need those to be in separate columns if you intend to import that into a different system later on. If you haven't taken steps to review and clean your data, you might find it hard later on to identify trends in the data, or you might find that some of your outcomes and your algorithms aren't as reliable. If you're using data to generate other outputs like word clouds, for example, you might find that those outputs are not very polished, as we just saw. So how you clean your data varies on a lot of different things, including your specific type of data and what you're using that data for. But common steps in this process involve resolving inconsistencies, properly formatting your data, and addressing null values. And we'll go over some of those more common steps. So in terms of resolving inconsistencies, that might include ensuring recurring values are correctly and consistently spelled when there are variant spellings of words or specific terms, including consistent case. So for example, If your data included names of provinces and you wanted to find out how many references to Manitoba were in the data set, you could in theory use Control F to see how many instances there are, but you won't get a reliable count if you haven't cleaned your data first. Some people may have entered Manitoba, but other people might have put MB or maybe MAN. Some people might have accidentally misspelled it. So if you're searching for Manitoba written in full, you might miss those variants of the term. Some inconsistencies might include near duplicates, like what we just talked about with different ways of spelling something, but sometimes you might want to verify exact duplicates as well. The data we're looking at today is asking people to select their favorite candy from a controlled list. So if the term coffee crisp or peanut butter cups is duplicated in different rows, that makes sense. More than one person is likely to enjoy the same kind of candy. But let's say two of those people who enjoy the same kinds of candy also have the same name and they come from the same province and town and they're the same age, then we might be talking about an accidental duplication there that we want to address and make sure that we only have one of those participants listed. Properly formatting your data is also another way to clean it. This might include steps such as converting numbers to the same value. For example, if your data has both kilograms and pounds, you'll want to convert them to a single value. You may also need to format your columns appropriately so that your software recognizes the type of data that you should be that should be in a given column. If one column includes dates, format it as a date field and use the same structure. For example, always have month, date, and then year, using 2 digits consistently for month, date, and 4 digits consistently for year every time. For numbers, format your columns so that the software recognizes that these are numbers and not text. Another way to clean your data up and more easily navigate through it is to think through what columns are valuable for your project. If you're reusing someone else's data for another purpose, maybe some of the values they've collected aren't important to you, and so you could delete them so that you can declutter your data a bit and only work with what you need. But if you are deleting a column, make sure there's no potential use for it that you haven't yet considered. So just think about, is it that I don't need this data, or is it that I just don't need it right now? And if you're unsure whether that column might be useful later on, you can always hide it instead of deleting it. So it's out of sight, out of mind. You can see more columns on your screen at once, but it's still there if ever you need to unhide it. You might also need to split or merge columns. If your data in those columns has a consistent structure, it's a lot easier to do through an automated process. But if it doesn't, then you might have to clean it up first. So for example, let's say your participants listed their 3 favorite candies in a single field and they weren't using any kind of controlled vocabulary or structure. It's going to be hard to split those cells in an automated way. Ideally, you could prompt software to split the columns up where there's a natural break. So you could say, split the columns up every time I see a column. But let's say someone used slashes or semicolons or numbers to split up their choices, then it's going to be a lot harder to apply those in an automated way. Another thing to consider, and this won't be as much of an issue in OpenRefine, but if you're working in something like Excel, if your data has a lot of rows to scroll through, you might want to freeze your top row where your headers are located. That keeps the top row visible no matter how far down you've scrolled, and so that way you can quickly tell what data you're looking at in any given column. Another thing to keep in mind when you're formatting your data is to think through and predict potential formatting issues that might come up if you're planning on migrating your data from one format to another. So for example, if you start out working in an Excel spreadsheet that's an XLSX format, you have the option to create multiple worksheets in a single Excel document. But if you're planning later on to convert that to a CSV, that only supports a single worksheet. So you would lose everything but that first worksheet in your document in that conversion process. If you keep that in mind at the start of the project, though, you might decide to create separate worksheets that only have a single sheet in each file so that you don't have that problem when you get to the conversion part later on. Null values are used when there is no value, and so the term null would indicate that a lack of value is different from a 0 value. So if I were to look at a data set created by someone else, and one question was, for example, how many times a week do I buy candy? A null value in that field would clarify that there is no value for this question. A 0 would indicate that the respondent buys 0 candy in a week. When we say null, we don't mean typing in the word null in a cell. We're talking about assigning that cell a value or a marker through an operator or a function. You can auto-populate null values within OpenRefine, and we'll look at that in a little bit. But for that to happen, your cells have to be truly blank. So if someone accidentally added a single space in a cell, it's not going to be flagged as a null value unless you catch that during your data cleaning. The term null can also refer to an error sometimes. A null error is something that can happen if your data isn't properly formatted, particularly when you're using formulas and operators. So for example, if you've used a formula in a cell that's not properly structured, you might get an error. So for example, the mode mult function should return the most commonly used value in a vertical row. To specify which cells you want to run in this formula, you need to have an operator to define the relationship between those cells. Using a colon between both cell values will clarify that you're running this on a range of cells. So in the example on the slide, it would be cells A2 and G2 inclusively. You'll get a null error if you use a space as a separator, for example, because that's not an accepted operator in those formulas. Another example on the slide shows a formula that is meant to add up values in a single, in cells that are included in parentheses. So the colon in that formula between A2 and A5 represents that you want to calculate the sum of the values from A2 to A5 inclusively. If you replace it with a comma, it would just add up A2 plus A5 and not include those cells in between. But if you do not have an accepted operator, that's where you're going to get an error message again. So to summarize, there are nulls that you want in your data to represent those places that have no values, but there are also some that you might want to pay attention to and address those errors. So in going through this, there's a lot to digest. And we'll go through the demo in OpenRefine, and it's going to make some of these things more tangible and more solid. But before we introduce you to the software we'll be working with, we thought it would be useful to briefly discuss what you can get out of data cleaning. So key benefits include more efficient research and use of your data. So for example, as we previously discussed, it's easier to locate information if it's expressed consistently. If you've removed irrelevant data, your data sets will be less cluttered, and it's going to be easier to retrieve the information you need and navigate through it. If you're working in a team and everyone is compiling parts of the overall data, you can work with one overall structure and format, and that way you don't have to readjust your way of interpreting and working through the data every time you open a different data set, just because one person's data looks different than another's and they have different systems and things like that. Everybody can work with a consistent format. Another benefit that'll make it easier when you get to the conversion process is thinking through what you need at the end of your project. So if you know what you're starting with and you know what conversions will take place throughout, that'll make the process easier. So whatever format you start out with, you may later require different formats to accomplish certain goals. If you're planning to upload your data to a database, that database might have specific CSV templates that your data has to conform to. If you're publishing your results and you want something visual to go along with it, like charts or graphics or a word cloud, you may need to reformat that data to suit those specific purposes. And it's likely that you'll need to perform some additional steps when you crosswalk your data from one format to another. But if you've done the data cleaning ahead of time, you're going to have a lot less headaches doing that because everything will be consistent and well structured. So they'll be easier to convert things that are only being converted for that specific format that you're moving towards if the data is clean and consistent from the beginning. Lastly, another advantage to data cleaning is secondary use. So this could be reusing your data for different purposes at a later time, but it could also be making your data accessible to others. If you don't clean your data, it might still make sense to you in the moment because you've been embedded in that process from start to finish and you have the full context. But if you come back to that data a few weeks, months, years later, it might not look familiar to you at all. You might not remember exactly why certain things are formatted the way they are. So just having nice, clean data will make that process a lot easier if you're intending to reuse the data. And if someone else is reusing your data, they don't have any of the context. And so clean data helps them better interpret your data if they want to reuse it as well. Good data should align itself with something called the FAIR principles, which stands for findable, accessible, interoperable. For example, if you're creating it in a Windows operating system, it should be able to be accessed in a Mac operating system as well as reusable. And all of those things rely heavily on a well-cleaned data set. Identifying long-term goals at the early stages of a project should inform how you clean your data, what needs to be cleaned, what needs to be reviewed, consistent, how it should be formatted. But today we're going to focus on a few common steps involved in data cleaning using OpenRefine so that we can create better word clouds in Voyant and have other great outcomes in our research. So with that, if you want to go find the hands-on exercise steps, they're at this link over here, and then I will stop sharing my screen and pass it over to Meg.
Great, thanks, Natalie. Now I am going to shuffle my screens around. I will share screen 2. Choose this one. Drag my bar over there. Okay. So I had sent the link to the OpenRefine workshop space earlier, and there was a link to download OpenRefine software. There is a link to download your data. There are 3 exercises in there. And what we're going to do is walk through this OpenRefine exercise that can be found in the tabs. To open up OpenRefine, when you unzipped your OpenRefine folder, what you want to do is open the one with the diamond. It's going to start up that little database. And I am just going to shift things around so you can see both of my windows. After the session, you are going to get a survey from us asking if you enjoyed it, what you would like to see more of or less of. In future semesters, we're going to offer a more advanced version of this session. But for right now, we are staying very basic, and what you will hopefully get out of it is an idea of how to navigate the OpenRefine interface and find some of those common transformations. So in terms of housekeeping, you can access all of your created projects by clicking on Open Project that is located on the left-hand side of your OpenRefine screen. And so you can see projects that I have created in the past, and you can see metadata about them. To edit the fields you see here, click on About to the left of each of these projects, and there you can see the number of available fields to edit. You guys probably won't have any in your OpenRefine already because this may be new to you. You can also see project ID that corresponds to the name of the folder in your work directory. In terms of naming, you can have multiple projects from the same data set or multiple versions from sharing a project with another person. OpenRefine automatically generates a project name from the imported file or the clipboard when you use clipboard importing, and project names don't have to be unique. So OpenRefine will create many projects with the exact same name unless you intervene. So always one of the first steps when you're importing is creating a meaningful name for your project. You can edit a project's name when you create it or import it, and you can rename a project later by opening it and clicking on the project name at the top of the screen. OpenRefine saves all of your actions, and actions are everything that you can see in the undo and redo panel. And auto-saving happens by default every 5 minutes. It doesn't, however, save your facets, filters, or any type of view you might have in place while you work. And this includes the number of rows showing and any sorting or column collapsing you may have done. A good rule of thumb is if it's not showing in the undo redo, you will lose it when you leave the project workspace. You can only save and share facets and filters, no other type of view, such as if you're hiding a row or hiding a column. To save current facets and filters, what you need to do is click on the permalink option, and that will reload with a different URL that you can then copy and save elsewhere. You can delete projects, which will erase the project file from your workspace directory on your computer. This is immediate and cannot be undone. And then you can share projects. Because OpenRefine only runs locally on your computer, you can't have a project accessible to more than one person at the same time. So it's not going to work like Google Drive. But what you can do is you can package it up. And so export your project as a package, and then the other person will import that project, make changes, package it back up, and send it back to you.
So in terms of creating a project, OpenRefine allows you to import data sets of different sizes, but there are some limitations that you should keep in mind ahead of importing a larger data set. So installing OpenRefine as is will allow you to work with a fairly large data set, as we previously talked about, so up to 1 million rows. But that number can fluctuate a little bit based on how much data you have per row, how many columns you have in the data set, etc. If you want to import data sets that have more than 1 million rows, you will need to increase the Refine server's memory, which is 1 GB by default. You'll also need to increase your RAM accordingly. Outside of OpenRefine, there are other limitations to consider. The software you've used to create the data you're importing into OpenRefine will have its own limitations on how much data it can handle. And if your intention is to export that data out of OpenRefine and into something else later on, it also might have some limitations in terms of how much data it can take in. So just knowing what those limitations are throughout the scope of your project and the life cycle of your project is good to know ahead of time. An OpenRefine project starts with importing your existing data into OpenRefine. OpenRefine does not allow you to create a data set from scratch in OpenRefine. So by importing your data, no matter where your data comes from, you're creating a copy of it. OpenRefine won't modify your original data source. So if you have it on your desktop and then you import it into OpenRefine, it's still going to live unchanged as it was on your desktop while you're making these changes in OpenRefine. So it creates its own project file, it stores it in your workspace directory, and when you start OpenRefine, you'll be taken to the Create Project screen. So you'll see on the left side of the screen that your options are to import data from your computer, the web, your clipboard, from a database, or from Google Drive. If you supply 2 or more files for one project, the file rows will be loaded in the order that you specify, and then OpenRefine will create a column at the beginning of the data set with the source URL or the file name to help you identify where each row came from. If the files have columns with identical names, the data will load in those columns. If not, the successive files will append all of their new columns to the end of the data set. You cannot combine 2 data sets into one project by appending data within rows. You can, however, combine the projects later using functions. When you start OpenRefine, it opens in your web browser. Your data is still only stored locally. It's not publicly available on the web. So don't worry, it's just that the web browser is the interface that the software uses to run the program. Once you've launched the program, you're going to click on Create Project. Then you're going to select Get Data From. And we're going to take this computer as our source. And then you're going to choose a file. So we're going to navigate to the spreadsheet we want to work with. And in this case, it's our exercise 2 CSV. We're going to open that. And then we're going to click next. And that should give us a preview of our data. Depending on the size of your data, it might take a long time, but we're working with a small set. So it loads fairly quickly in this case.
And depending on what your screen size is or how you have your desktop set up, it might look slightly different than mine. So you can see that I've got one row that's squished in really tightly, and I've got some spaces between different columns and different rows. So yours may look slightly different to mine. So don't worry about that. It's just in how it loads. So this is your project preview. And for a lot of people, it might feel very intuitive to just say, yep, that's fine. Let us move on to the next step. I want to create the project. But this is really where you need to stop for a minute and be like, okay, what do I actually have? Is everything showing up the way I'm expecting it to? Because this is how OpenRefine is parsing your data or reading your data. And you can see a preview of, for me, the first 13 rows and the first 6 columns. At the bottom of your screen, you can see the options for telling OpenRefine how to process what it's found. You can tell it which rows to parse as column headers. For me, it's properly reading that first row is a column header, and as well as ignoring any other rows that you need to ignore. You can also select only a specific range of rows to work with. Say you only wanted to work with rows, 100 to 245, you would be able to do that. But remember, it's doing it as its best guess based on the file extension. The main thing to look at here is character encoding. So we know that, I know that this data set was created using UTF-8, and the encoding that it is thinking it has is Windows 1252. So if we click on that dropdown, it gives us a pop-up, and we want to change that to UTF-8 Unicode so that it picks up the accents and the special characters that we have in our data set. And now we'll be able to see that the province of Quebec, farther down in the data set, will have its accents being displayed properly and that kind of thing. And note that OpenRefine does not preserve any formatting such as cell or text color that will have been in the original file when it came out of Microsoft Excel, for example. Hyperlink text will be input as plain text, but OpenRefine will recognize links and make them clickable inside the project interface. And you want to make sure your data looks right in the preview window, and then give your project a name in the top. I guess that is the middle of the screen where it says exercise 2 CSV. That is where you can change its name. I'm going to call it Halloween Candy Survey, except spell Halloween correctly. And a great thing to do is, if you know you're going to be doing a lot of data cleaning, is to start assigning some tags to your data sets, so you know you can keep track of them a little bit more easily. And once you have named your project, you can click Create Project. What I'm also going to point you here to is that OpenRefine automatically stores blank rows and you can set it to store blank cells as nulls. So you're setting your nulls up on import. That can be a useful thing for you to do as well. You can also do it later on, and we'll talk about that. So I've named my project Halloween Survey, and then I'm going to click Create Project.
All right, so once it loads, you should see something similar to this. And the first thing we're going to do is look at field transformations and how to undo some actions. So in many cases, some transformations or actions will require a certain field type. So to specify that the field includes number or dates, we want to make sure that OpenRefine recognizes that that's what those values are. So we'll work with question 3 to walk through how to change a field type in a column, which is the age column. So right now it's being formatted as text, and we want it to recognize that those are numbers. So we're going to select the drop-down arrow beside the header in the age column. And then
I was going to say, if you do get lost, each of the headers, each of the columns is labeled as what question or section of the walkthrough we're on. That helps.
So then click on the drop down, and then you're going to see an option that's edit cells. And we're going to go to common transformations, and then we're going to go to number. So your column should now look similar to what's on the screen. The numbers have shifted to the right. They're all in green now, designating that it's a numeric field. If at any point you want to undo an action, you can click on the undo redo option on the left side of your page and select the step that you want to revert to. So for example, if you wanted to undo this step, you would select the step we performed right before, but in this case, this is the first step. So you basically go to create project. You can also use this panel as a bit of a log for the steps that you've applied. So if you're going to be doing all of these steps and you have other data sets later on where you want to redo all of these same steps on those other data sets, you can use this as a way to look at what you did to each of the data sets prior to make sure that you're applying all those actions consistently as well.
Great. So another thing that we might want to do is do upper and lowercase transformations. So sometimes your data will have inconsistent font casing between different entries. And this is especially true if you're combining different data sets. In our case, we want all of our entries to be in title case. So for our Q4 Canada, we want it to be Canada with a capital C, lowercase ANADA. And so to do that, what we do is we select our drop-down arrow beside the header for country. And then we go down to edit our cells because we are editing that cell content. Once again, we're going to go to common transformations. And then we're going to say to title case. You'll notice at the top of your screen, it will flash you a little message to say that how many cells it has transformed. And there is the option to undo, but then it disappears on you.
So the next thing we're going to do is faceting. Faceting provides you with a snapshot of the entries in a particular column and allows you to filter down the particular rows. It's a useful way to quickly highlight problems within the data. So the facet summarizes the cells in that column to give you a big picture of that column, and it allows you to filter to some subset of rows for which their cells in that column satisfy some constraint. For this step, we're going to work with Q5, the state, provinces, county, etc. column. We're going to click on that drop-down arrow again on the column to bring the drop-down menu down and choose facet. And then we're going to select text facet. So then you'll notice that in the left margin, you'll see a box containing every unique distinct value in the provinces column, along with a count that shows you how many times that value appears in the column. Both the spelling and the case determine whether that value is unique. So for example, Alberta with an uppercase A and Alberta all lowercase are two separate values, even though they're spelled exactly the same. There are 29 instances of Alberta with an uppercase A, and there are 2 with a all lowercase. So as you can see, the provinces have been recorded in different ways. So note that at any time in any cell of the facet box as well, or data cell in the refine window, you have access to edit and you can fix an error immediately. So OpenRefine even asks you if you'd like to do that same correction to every value it finds like that, or just one or the other. So if you clicked on that edit button, you could quickly make a change to make sure that Alberta is spelled consistently.
But there's a smarter way or a different way in that you can use clustering to clean up your data set. So clustering uses AI and fuzzy matching to take a best guess at which pieces of text might actually refer to the same thing. You can play with the method and the keying function to change the types of algorithms that it's using to fuzzy match. But for us, we're going to leave the defaults because it does a pretty good job. So to do that, in our filter facet window, we're going to click on the cluster option that's in the top left corner of the panel. And it opens up this clustering wizard. You can see that the method it has selected is key collision. Could have chosen nearest neighbor, and it's using fingerprint as the keying function. And what it's trying to do is cluster together those things that it thinks should be the same thing. So when you're looking at your clusters, what you want to do is make sure that you are selecting the checkbox that you actually want to merge. So for this case, in this case, for the top one, Ontario, I'm going to say, I want to cluster these 4 items together, and I want to merge them. And I want my new cell value to be Ontario title case. Then what you can do is, as we move down this list, you can continue to make those edits. So instead of saying what we can do for BC, we know that we want that to be British Columbia instead. So we can say, yes, please, I would like to merge these 3, but instead of the new cell value being BC, I'm going to type in British Columbia. And I will just continue down this list, merging and clicking and typing things in. On our third option with Manitoba, you can see when you click in that text box that it's actually saving it as Manitoba with a space after it. We don't want that. We want to remove that trailing white space. We could have snipped that out at the very beginning when we previewed, but in this case, we chose not to. But that's something you can do as well, is make sure that you are taking care of those invisible spaces. For this one, British Columbia, I'm going to be merging these 3 together. British Columbia with a capital B, capital C. Quebec, I actually want the one with the accent. So I'm going to copy Quebec how I want it to look. And I'm going to paste that into my, my field. It will preserve that because we selected UTF-8 at the beginning. And then we can continue on down that list for Alberta. Looks good. My ONs are going to become Ontario. Nova Scotia is going to become Nova Scotia title case. My ONTs are going to become Ontario. And my Newfoundland is uppercase and lowercase is going to become Newfoundland. Once you've made those edits, what you can do is click on Merge Selected and close. And it tells us that we have done a mass edit. Before we started merging, there were 43 different values in the province column, and now we're down to 23 different choices, meaning we were automatically able to clean 20 values in our data set. And the program does a great job at matching of the correct values, but as with anything automated, you should go through and look at your data for discrepancies. For example, we still have Alberta with 3 entries in that we have AB in capitals, Alberta with a Q and 2 R's, and then Alberta how we want it to be spelled with 31 records. And because the algorithm doesn't know that all 3 of those refer to the same thing. And so at this point, you could either go and rerun that clustering algorithm, or you could say to yourself, you know what, it's only 23 choices. I can quickly do this manually. It is completely up to you. There's no right way or wrong way to do it. Just think of this as a tool that is here to help you out.
So the next thing we're going to do is merge multiple columns together. So question 6 in the survey asked respondents to select their top 3 candy choices from a list of 8. And each of these 3 choices is included in an individual column in OpenRefine right now. So we're going to try and merge these columns into one with each of the 3 values separated by a special character. So in this case, we're going to use a pipe character, but this could be a comma, a semicolon, depending on your data set. So we're going to find Q6, the first fave candy column, and we're going to click on the drop-down arrow to bring the drop-down menu down, and then we're going to choose Edit Column, and then we're going to select Join Columns. So you're going to get a dialog box that opens, and you'll notice at the top that the column you selected is already checked, but you need to add other columns to join. So we're going to check the box next to the Q6 second fave candy and Q6 third fave candy. And then in the top field under select options, separator between the content of each column, we're going to enter our pipe character to say that when we merge these, we still want something to separate out our 3 merged values, and we want that to be the pipe character. And then we're going to check write result in a new column named, and here we're going to enter our new column name, which will be Q6 : top 3 candies. And then we are going to click OK. And then we should have a new column. So in this case, we kept the original columns. They're still there. It doesn't delete any of the columns that we've merged. And if you want to delete those extra columns, this gives you an opportunity to quickly review the new one alongside the 3 old ones and make sure that things successfully merged. And we'll go over how to delete the column if you want to in a later step.
Another thing you might want to do, which the opposite of joining a column, is maybe you want to split your columns. And we can see if we scroll over in our geotag column that it has both latitude and longitude in the same column separated by a comma. And to visualize this in a GIS software, these would need to be in separate fields. So what you need to do is find the Q8 geotag. And what you want to do is click on that down arrow. Beside the down arrow, we're going to edit column because we're editing the structure. And then we want to split into several columns. In our wizard that opens, what we want to do is we want to say we're using that separator. So we're using that comma that exists in the field. We've typed, it has parsed out that comma. We want to have our comma in there. Then we want to say guess cell type, and we're going to remove, in this case, that geotag column. You could also split by field tag length or field length if you knew that you wanted to split your column up after like 7 characters or something like that. Lots of different ways to do that. So we're going to have our separator be our comma. We're guessing the field type, and we're removing that initial column. So then we will say OK. And you can see our geotag field has now been split into 2, but some of them didn't split. And if you look closely, you can see that that one was missing a comma, and so that's why that split didn't happen. A way you could quickly review that instead of scrolling through your data to see how many of them didn't split would be to use those facets or filters again to just say, oh, which one has, or to see which one has a bunch of characters in it. But the other thing we're going to want to do is now we have columns that don't necessarily have meaningful names. And so to change the names that have been automatically assigned, what we want to do is click on that drop-down arrow beside Q8 geotag 1. And then we're going to go down to edit column again. And then we're going to go over to rename this column. We're going to rename the column with the positive values as latitude. And then we're going to repeat that for the column beside it with our negative values as longitude. So drop down arrow beside Q8, down to edit column, and then down to rename this column. And now I have my data that is separated into, or my location data that is separated into 2 columns, and I would be able to import this easily into a GIS.
Next, we're going to look at deleting a column, which you might want to do, but use caution when you're doing this and be sure you don't require that data. Find the column titled blank column, which is between Q8 and Q9. And we're going to click on the drop down arrow. We're going to select edit columns, and then we're going to click on remove this column, which is about in the middle of the drop down menu. And then your column's gone. If you might need a column later, but you just don't want it right now, or you don't want it kind of taking up space on your screen, you can also hide it. If you're using something like Excel, it talks about hiding and unhiding columns, but OpenRefine refers to it as collapsing or expanding, but it's the same idea. So let's say we wanted to hide or collapse our province column. We would click on the drop-down arrow for that column. And we would go to view. And then we would select collapse this column. And so there are a few ways that you can make that column come back if you wanted to see it later. So you'll notice it's not fully gone. There's a narrow column in between the 2 questions on either side of it that still is there. And theoretically, if you wanted to just quickly bring that one column back, you could double click on where the header field is for that narrow column that's still left behind. A second way of doing it is and that we'll walk through this option, is by going to the all column, which is the first column of our data. So click on the drop down arrow for that all column, and then on view. And you'll also notice here that we have options to show or hide null values, but we also have options for our columns. So we're going to select on expand all columns, and then that column will come back. If you notice the all column under the view options, there was just the option to expand or collapse all of the columns. But if you selected any other columns, you'd also have the additional option to expand or collapse all the columns to the left of the column you've selected, or all the ones to the right you've selected. So that's another way that you could potentially expand or collapse your columns. Another thing to note about that is that we've applied these actions, but they're not actually recorded in the undo redo actions that we have on the side. So it's not something that if you wanted to hide something and you accidentally hit the wrong thing, you'd still have to unhide it. You couldn't just quickly undo an action because it's not logged as part of that undo redo panel.
And additionally, there's an option to show and hide a label to see if your cells are truly null under that same all option. So under the all drop down, if you go down to view, you can see show hide null values in your cells. And if you turn that on, you get a little gray null that shows up in your cells, which are actually null. And that can be useful to have on. In terms of advanced OpenRefine techniques, the 2 things I'm going to point out are GREL. So OpenRefine has its own language referred to as GREL, General Fine Expression Language, for performing custom operations. And this would be similar to functions in Microsoft Excel. And it was created to resemble JavaScript. So there is a reinterpret function to change that column encoding that we talked to from like UTF-8 to something else, or uniques, and that will return an array with duplicates removed. So just know that we today have talked about very general introductory ways to clean your data, but you can go much more in depth with it. The other thing that I'm going to point out now, because we get a lot of questions about them, are your nulls. And say you realized after you imported your data that you forgot to assign a null value to empty cells, or you realize that you want to find all cells without values to be able to work with them. And the easiest way to do that is through the facets panel. And so to do that, you can select any column. In this case, I'm going to choose Q7 because I know that there are null values in there. And I can click on that drop down arrow. Then I'm going to facet. And I am going to go down to customized facets. And you can see there are a ton of different facets if you're looking for duplicates, if you're looking for different text lengths, those types of things. But the one that we want to do is we want to facet by null. You can also facet by error. And so we can see then that we have 196 records that truly fit that null, or we have 31 records that are not nulls. So that is a way to subset out that data. And so then if you were doing more advanced procedures, what you could do is say, okay, I am only interested in the ones that are true. And then I could go and do my procedures to this subset of that broader set of data.
So once our data is ready to go, it's been cleaned up, we're going to move on to exporting our data out. So remember that when we're making changes in OpenRefine, it doesn't actually apply those changes to our local copy that we originally imported. So to get that copy onto your computer, you're going to click on the export button near the top right-hand corner of your browser window. And we're going to select comma separated value, CSV. And then it'll give you the option of saving your data somewhere to your local computer, and you can move the file to the appropriate directory. And now you successfully exported a clean copy of your data.
Congratulations. Okay. So I am going to stop recording.